All right, so we're using now secant and tangent. So it's very similar to what we did with sine and cosine where we're using u substitution. So we have these basic ideas here. If you see that the secant power is even, and these are going to make sense. You don't have to memorize these, just to understand them. If it's even, then we're going to save as secant squared, because if we use u equals tangent, that's going to give us du equals secant squared x dx. And if it's even, that means we're still going to have an even power with the secant that we can use to replace with the tangent. Now, if the tangent power is odd, that means we want to pull one of the tangents off, because again, we're going to get secant tangent. So over here, we would get du equals secant x tangent x dx. And you see there's the little odd that we're going to be using from the tangent, and now we can still use the tangent to replace them as secants, and everything will work out perfectly. So if you see secant power even, we pull off a secant squared. You see tangent power odd, you pull off a tangent. All right, so this one is obviously secant power is even. So we're going to leave the tangent alone and pull the secant apart. So there it is. That's the one that we want. So now we know that we can go, well, u will be tangent theta. And so our du would be that secant theta squared d theta that we wanted. All right. So now all we have to do is make sure everything is tangent so that we can substitute it, other than that one little secant squared. So this one we can now replace with 1 plus tangent squared theta. And this is just our double angle identity again. And there you go. So now we can replace everything, u to the 6. So these are very similar to the sine and cosine. You just have to know what your u substitution is going to give you, and so that tells you what to pull apart. What the heck is wrong with me? There we go. That's a u. u6 plus, I guess it's sort of a 6. A u, I mean. There we go. All right. So this is 1/7 u to the 7th plus 1/9 u to the 9th plus c. All right. So now we end up with 1/7 tangent 7th theta plus 1/9 tangent to the 9th theta plus c. And there we go. All right, so the next one, obviously we need to deal with a tangent is odd. So now if we have a tangent power odd, we're going to pull a secant tangent away from it. So this would become tangent to the 4th theta, secant to the 6th theta. And the secant we don't really care about. It's going to be going along for the ride because he's the u. So we're going to get secant theta, tangent theta, d theta. See, that's what we were looking for right there. So that way we can say, well, u is secant theta. So it's just a quick little trick that if you see that tangent's odd, pull one of the tangents off and use that. All right. By the way, there still has to be an extra secant in there as well for this to happen. So, all right. So du is equal to secant theta, tangent theta, d theta. That's what we wanted. So now we can go back, and you notice everything for u has to be secant. Then by pulling that one tangent off, so by ripping that 5 and taking 1 away from it and leaving a 4, we made this also even. So now we can say, right back up there, that secant right here, right there, their tangent squared is secant squared minus 1. If you forget it, it's right there. So secant squared theta minus 1. And again, that's a square, so we need to square that to make it work. I know I'm skipping a little step here. Secant 6 theta. So again, tangent to the 4th would just be tangent squared theta squared. And so this would just become secant squared theta minus 1 squared, which is what we have there. And then now we can replace that with du. Everything now is secants, right? So I'm going to do this all in one shot, though. So this now is du, this right here. This becomes u to the 6th, u squared minus 1 squared. And there we go. Now we multiply this out, u to the 4th minus 2u squared plus 1. And then we just have to multiply that u to the 6th in there. So we end up with u to the 10th minus 2u to the 8th plus u to the 6th du. And we integrate, plug everything in, we're done. So 1 to the 11th, u to the 11th minus 2 over 9, u to the 9 plus 1 over 7 u to the 7 plus c. Write our answer. So secant to the 11th theta minus 2 over 9 secant to the 9th theta plus 1 over 7 secant to the 7th theta plus c. Okay, so what if we have cotangent and cosecant theta? Well, we're going to use the same idea, but we're going to use this identity. So cosecant squared would just become cotangent squared plus 1. And cotangent squared theta would equal cosecant squared theta minus 1. So you see, they're the same basic idea. It's just cotangent and cosecant as we do it. So similar. So if we have a secant even power, in this case a cosecant even power, we're going to save a cosecant squared. And if we have a cotangent odd power, then we're going to save a cosecant cotangent. So let's see what we have here. We have a cotangent odd power, not a cosecant even. So we're going to be taking out and saving a secant tan. So in this case, we're going to be saving a cosecant cotan. So we end up with cotangent to the 4th theta, cosecant to the 6th theta. Oops, I can't get rid of them. Cotangent theta, I'm going to eventually, but cosecant theta d theta. So this means that what we're doing here is we're taking and saying u is cosecant theta. And so our du would equal cosecant theta, cotangent theta, d theta. Just remember the cos give us a negative. So this is really negative du equals cosecant theta, cotangent theta, d theta. So now that is what we get to replace. Now everything else needs to be cosecant. So that means our cotangent is the one that we need to replace. So you notice it's the same basic idea. We're doing just like we did with the tangent, we're just calling it a cotangent. So same thing. See how this one had a tangent need to replace, this one's a cotangent. So we're going to replace our cotangent to the 4th with cosecant squared minus theta, minus 1. You can see it's exactly the same steps. All I did was change tangent to cotangent and secant to cosecant. So we can just really just follow along the steps we did there, and it works the same way. Okay, so now it's all set up nicely to be replaced. This goes away. Everything else now is a u. So this is u squared minus 1 squared, u to the 6th du, but we do have a negative now outside. So that is the only difference. You see it's all here. So we can just now skip ahead. It's going to be the same idea. We distribute, we get this, and now we throw in the negative. So negative 1 over 11 u to the 11th plus 2/9 u to the 9th minus 1/7 u 7th, and last is just a constant, so leave it alone. So it's the same thing up there too. So it's negative 1/11 cosecant 11th theta plus 2/9 cosecant 9 theta minus 1/7 cosecant 7 theta plus c. So you can see the cosecant cotangents work exactly the same way. So you're good to go.